we saw something that almost nobody noticed. And honestly, it hasn't let me sleep since. Because we think the day of real space exploration isn't that far away anymore. We think the time has finally come for us to leave this Earth behind. But before we get there, we need to understand something. Is space exploration actually possible? Practically speaking? Because if you look at it realistically, it's basically like trying to open an umbrella inside Donald Trump's mouth. It tells you one thing very clearly. The road ahead is still very, very long. Now, Starship's 12th flight was as spectacular and thrilling as ever, but things were also, as always, a complete mess. Because SpaceX still hasn't managed to get everything right. But you know what? That's not our problem. We're just here to enjoy the ride, so let's go. Buckle up and dive into this journey through space together. Close your eyes for a second. Imagine you're standing in an open field in South Texas. It's early morning. The air is still. And about 3 miles away, something is sitting on a launch pad that your brain genuinely cannot process the scale of. It is taller than a 40-story building. It weighs more than 3,000 tons fully fueled. And in a few moments, it is going to attempt something that no machine in human history has ever successfully done before. You don't hear it at first. You see it. A flash of white light at the base. Then a wall of fire so wide, so violent, that it looks less like a rocket launch and more like a small volcanic eruption deciding to move sideways. Then the sound hits you. Not a sound you hear with your ears. A sound you feel in your chest, in your jaw, in the fillings of your teeth. A deep, physical, overwhelming pressure wave that tells every primitive part of your brain, something enormous just happened. That is Starship Flight 12, the debut of a brand new rocket, a brand new engine, a brand new vision of what it actually looks like when our species decides, seriously decides, that this planet is not our final destination. It didn't all go to plan. But then again, nothing this important ever does. October 2025. That was the last time this rocket left the ground, 7 months ago. And if you follow this program closely, you know that 7 months of silence from SpaceX means exactly one thing. Something big is being rebuilt from scratch. Think about what that actually means. You have the most ambitious rocket program in human history. A company that has publicly stated it wants to put humans on Mars within this decade. And for 7 months, nothing. No launches, no tests. Just engineers, welding torches, and a deadline that the entire future of space exploration is quietly waiting on. What were they building during those 7 months? Everything. A completely new Starship ship stage, a completely new super heavy booster, 33 brand new engines that had never once fired in the real world, and an entirely new launch pad, constructed from the ground up, designed not for occasional launches, but for something that sounds almost absurd when you say it out loud. Several launches, per day. From a single pad. Sit with that for a moment. Right now, launching any rocket to space is a months-long operation. NASA's most advanced missions take years of preparation for a single flight. SpaceX is building infrastructure for the same pad to send the world's largest rocket to space, multiple times, before the sun goes down. That is not an upgrade. That is a completely different relationship with space travel than anything humanity has ever attempted. But on the morning of Flight 12, none of that future existed yet. There was just a brand new rocket sitting on a brand new launch pad, surrounded by engineers who had spent 7 months betting everything on systems that had never once been tested at full scale. And the only way to find out if any of it actually worked was to light the engines. The morning of the first attempt, the energy was different. You could feel it in the way the cameras moved, the way the commentators spoke. Even the silence between words carried a kind of weight that only comes when something genuinely historic feels close enough to touch. The countdown was running. The rocket was fueled. 33 brand new engines were sitting loaded and ready, waiting for the signal that would send them all igniting simultaneously for the very first time. The clock hit 0. And nothing happened. Not a dramatic explosion. Not a catastrophic failure. Just silence. A hold. And then the quiet, deflating announcement that the launch was scrubbed. The reason? A pin. One single pin inside one single arm on the launch tower had gotten stuck in place. The quick disconnect arm, the mechanism that delivers fuel to the top of the rocket and then folds back just before launch, simply refused to move. And if that arm doesn't clear the rocket in time, you don't launch. No override, No workaround. You shut everything down and you start over. One pin. On a rocket with 33 engines, 40 meters of new launch pad infrastructure, and 7 months of engineering behind it. One pin brought the whole thing to a stop. There's something almost poetic about that, a reminder that complexity has no ego. It doesn't care how sophisticated the system is. The weakest point is always the weakest point. But while engineers worked through the night to fix it, the scrub gave the world an accidental gift. A front row seat to watch SpaceX load fuel into the largest rocket ever built in 30 minutes. For comparison, NASA's Artemis II, a smaller rocket, takes over 3 hours to do the same thing. 30 minutes versus 3 hours. That gap doesn't just tell you about fuel systems. It tells you about two completely different philosophies of what space travel is supposed to look like. Every revolution in human history has had a single invention at its center. The steam engine didn't just power factories. It rewired civilization. The transistor didn't just process signals. It made the modern world possible. And right now, quietly sitting inside the base of the world's largest rocket, is something that could one day be spoken about in exactly the same breath: the Raptor V3 engine. To understand why this engine matters, you have to understand where it came from. The original Raptor, V1, was born in a laboratory. It worked, but it looked like it. External pipes running along the outside, wiring bundles wrapped around the casing, sensors mounted everywhere. It was a proof of concept wearing its own uncertainty on the outside, like a student who got the right answer but couldn't quite explain how. Then came V2, cleaner, more powerful, good enough to fly every single Starship mission to space so far, but still shielded, still protected, still carrying a quiet vulnerability that showed itself at the worst possible moments. V3 starts from a completely different question. Instead of asking, how do we protect this engine? SpaceX asked, what if the engine didn't need protecting at all? Everything that used to live on the outside, the sensors, the plumbing, the wiring, has either been deleted entirely or moved inside the engine itself. The result is a machine so clean, so stripped back, so confident in its own design that it sits completely exposed on the booster. No shielding, no armor, just 33 engines hanging open in the South Texas air like they have nothing to hide. And that simplicity has a number attached to it. 1 ton of saved weight per engine across 33 engines. That is 33 tons removed from the booster before a single drop of fuel is loaded. In rocketry, 33 tons is not a small number.
It is the difference between reaching orbit and falling short, between carrying a payload and carrying nothing, between a rocket that works and one that almost works. But the single most dramatic thing V3 enables isn't the weight saving. It isn't even the cleaner design. It is this. A new fuel transfer tube, running straight down through the center of the booster like a spine, roughly the same diameter as an entire Falcon 9 rocket, now delivers methane directly into the engine bay with enough flow rate that all 33 Raptors can ignite at the exact same instant. Not in sequence, not in groups, not building up power one section at a time. All of them, together, simultaneously. The ground doesn't just shake when this rocket launches. It surrenders. The second attempt. The pin was fixed. The crews had worked through the night. The rocket had been refueled in 30 minutes. And this time, when the final seconds of the countdown disappeared, the sky answered. All 33 Raptor V3 engines ignited simultaneously. And the word ignited doesn't do it justice. This wasn't a controlled burn. This wasn't a gradual buildup of power. This was 3,000 tons of steel and fuel deciding in a single violent instant that it was done with the ground. The shockwave arrived before the sound did, a physical wall of compressed air that hit spectators miles away like a soft punch to the chest. Then the sound followed. Not a roar, not a rumble, but something lower and more primal than either of those words suggest. Something that bypassed the ears entirely and registered somewhere older. Somewhere in the body that doesn't have language for what it just experienced. And the rocket was already gone. 30 seconds after leaving the pad, Starship was moving at over 500 kilometers per hour, already 2 kilometers above the Earth, 25% faster at liftoff than any previous flight. The atmosphere wasn't an obstacle. It was barely an inconvenience. Then came the moment that everyone watching had been waiting for, hot stage separation. This is the point in the flight where the Super Heavy booster and the Starship part ways. But unlike every other rocket ever built, they don't part quietly.
The ship fires its own engines while still physically attached to the booster, blasting 6 Raptor exhausts directly downward into the structure below, so that the combined vehicle never once stops accelerating on its way to space. For the new V3 rocket, SpaceX redesigned this entire connection, the old hot stage ring, a separate adapter that used to sit between the 2 stages and get thrown into the ocean after every flight, is gone. Now the top of the booster itself absorbs the separation forces, reinforced steel plating, an open triangular framework that lets the exhaust escape in controlled directions. A design that looks, on paper, like it has finally solved one of the most violent moments in any rocket flight. The ship engines fire. The booster gets pushed away. The 2 stages separate cleanly. And for one perfect moment, everything is exactly as it should be. Then the booster tries to flip around, and the flight changes completely. Watch this moment carefully. Not because it's spectacular, though it is. Not because it's dramatic, though it absolutely is. Watch it carefully because what happens in the next 40 seconds is one of the most brutally honest conversations a machine has ever had with the humans who built it. After separation, the super heavy booster has one job.
Flip around, relight all 33 engines, and perform the boost back burn. A controlled, precisely calculated deceleration that slows this 200-foot tower of steel down from hypersonic speed and sends it falling back toward the launch site. The flip begins. Clean. Controlled. Exactly as planned. Then the engines try to relight. Try. Watch the footage frame by frame if you can. You can see them catching. Small bursts of orange flame appearing at the base of the booster as the Raptors attempt to ignite. Then immediately dying. Then trying again, then dying again, one by one, in a sequence that feels less like a technical failure and more like watching something desperately fighting to survive. 33 engines were supposed to light. For a brief moment, maybe 8 are running, then 4, then 2, then none. The boost back burn never happens, and without it, physics takes over completely. This booster, this brand new, 7 months in the making, most expensive single component in the history of rocketry, is now a 200-foot metal tower in free fall. No engines, no control, no way back. The onboard camera captures everything, the horizon tilting as the booster begins to spin, the cloud layer rushing upward to meet it, the first faint orange glow appearing at the edges of the structure as the atmosphere begins to push back. Then the shaking starts, subtle at first, then violent, then beyond what the camera can hold steady, as aerodynamic pressure builds against a vehicle that was never designed to survive what it is currently experiencing. Then a flash of fire rises up from the base, and the feed goes dark. The booster is gone, and the silence that follows that dead camera feed carries a specific weight, because this wasn't supposed to happen. Not this time. SpaceX had specifically redesigned this booster to prevent exactly this sequence of events. New engines, new hot stage connection, new grid fins, each one 50% larger than before, repositioned for maximum control during descent. Every single change was built on the lessons that previous boosters had already paid for in fire and falling debris. Same lesson, same result, different rocket. For a few seconds, watching that dark screen, you feel the full, unforgiving weight of what it actually means to build something that has never existed before. No manual, no blueprint from someone who succeeded before you. Just physics and engineering and the humbling reality that the universe doesn't grade on effort. It only grades on outcome. But somewhere above all of this, about 80 kilometers higher, still climbing, still accelerating, still fighting, the ship is not done yet. There is a moment in every Starship re-entry that no human language was really built to describe. It happens at the edge of the atmosphere, that invisible boundary where space ends and Earth begins. Where a vehicle traveling at 27,000 kilometers per hour, nearly 8 kilometers every single second, begins to meet air molecules for the first time since launch. At that speed, air doesn't part. It compresses. It heats. It turns into a wall of plasma so hot that the surface of the vehicle glows like a small piece of the sun, dragging a tail of fire across the sky, visible from hundreds of miles away. This is re-entry. And for Starship, it is the most violent, most beautiful, and most unforgiving part of the entire flight. The ship comes in belly first. Its massive heat shield. Thousands of individual ceramic tiles covering the entire underside, absorbing temperatures that would reduce almost any other material to vapor. The wing flaps move constantly, making thousands of micro-adjustments per second, steering through the upper atmosphere using nothing but the angle of the vehicle against the airflow. Then the flip.
The ship rotates from horizontal to vertical in midair, a maneuver so counterintuitive, so visually impossible, that the first time you see it, your brain briefly refuses to accept what your eyes are showing it. 2 of the 3 center Raptors ignite. Not all 3. 2. Enough. Just enough to arrest the descent, slow the fall, and bring 30 meters of spacecraft down to the surface of the Indian Ocean in something resembling control. And then, as always, the final explosion as the vehicle meets the water. But before the fire takes everything, one last image. The heat shield tiles close up, filling the frame, and they are perfect. No burn-throughs, no missing sections, no melted edges or stress fractures or the charred, wounded look of something that barely survived. On every previous flight, these tiles came back looking like they had been dragged through hell, cracked, blackened, pieces missing entirely. This time, clean, almost untouched, like a vehicle that didn't just survive re-entry, but mastered it. For a ship that lost an engine on the way up, survived a complete booster failure below it, and flew the entire upper atmosphere phase on 5 engines instead of 6. Coming home looking like that is not just a good result. It is a statement. Step back for a moment. Not from the failures, not from the explosions or the dead camera feeds or the engines that refuse to relight. Step back from all of it and look at the whole picture. Because here is what actually happened on this day. A brand new rocket, never once flown before, left the ground with a force that made the Earth itself shudder. It survived an engine failure in space that would have ended every previous version of this vehicle. It deployed payloads in orbit. It showed humanity, for the first time, what it looks like to watch a satellite leave a spacecraft from the satellite's own eyes. And it came home through the most violent re-entry environment our atmosphere can produce, and landed with a heat shield that looked like it had barely broken a sweat. All of that happened on the same day, on the same rocket. Yes, the booster was lost. Yes, engines failed at critical moments. Yes, there is still a long list of things that did not work the way they were drawn on paper. But here is the thing about this program that its critics have never quite understood. SpaceX doesn't need perfection. They need data. Every explosion is a conversation. Every failure is a question the universe is asking, and the engineers are writing down the answer. Every dead camera feed is a data point that makes the next flight smarter, faster, more capable than the one before it. This is how Flight 1 became Flight 12. Not through perfection, through iteration, through the willingness to light the engines, knowing that something might go wrong. Because something going wrong in a test is infinitely better than something going wrong when there are humans on board. And that moment is coming. Humans on Starship. Not as a concept, not as a render in a presentation, as a reality. Astronauts sitting inside this vehicle, trusting every tile, every engine, every pin on every quick disconnect arm. Trusting all of it with their lives. That is what Flight 12 was really about. Not the launches we saw, but the launches it makes possible. The Moon, Mars, the quiet, profound, world-altering idea that the generation alive right now might be the last one for whom leaving this planet feels like science fiction. Flight 13 is already being prepared, and somewhere in the data from today, in the engine logs, the thermal readings, the pressure signatures from 33 Raptors that tried and failed and tried again, somewhere in all of that is the answer that makes the next one work.